class. We're starting our next lesson 11.11, homework 11. We're working with ratios. Y'all remember what ratios are? I'll tell you. Ratios are fractions. Okay? Now we're going to be comparing two similar objects, and I believe we did this already before with similar shapes where we have developed ratios, and the only way they can be similar if the scale factors were equal to each other, if all the sides of both objects created equal fractions or equal ratios. So what's going to happen with these similar solids, these are going to be 3D figures, and you're going to be getting linear measurements. Okay, so what are linear measurements? And if you look at your notes, it can be length, it can be width, it can be height, it can be slant height, it can be the perimeter, the radius, the diameter, or the circumference. Any of those are linear measurements. In other words, you're going to be comparing length to length, width to width, height to height. Don't mix it up. If you have two figures, you're not going to compare the width of one to the height of the other. You match them, okay? The width with the width, the height with the height. Or if you're dealing with a pyramid or a cone, the slant height with the slant height, okay? Or the circumference with the circumference. You do not mix them up. So when you compare these fractions, you're going to have to see, are these fractions equal to each other? So if we're looking at number 1 here in our examples, we have a pyramid, okay? And the directions are determine whether they are similar or not. Yes, you give the scale factors. So you're going to compare the three or the measurements that they give you. For instance, for number 1, here you have the height of the pyramid, of the bigger pyramid, and you have the height of the smaller pyramid. So we're going to compare 12 and 3. This is going to be one fraction. Then you're going to compare the width here with the width on the other one. Remember, you do not mix them up. So it'll be 8 over 2. Then lastly, you're going to compare this length right here to the other one. 20 over 5. We have each one set up, and they're like, well, they don't look the same. You have to simplify. Okay? You will have to simplify your fractions. Okay, this is basic elementary. You will have to know this. Okay, so 12 over 3 is actually 4 over 1. 8 over 2 is 4 over 1. 20 over 5 is 4 over 1. Each one of these is equal to each other. So yes, these are similar. We'll look at number 2. We're comparing these. Again, we're trying to see, are they similar or not? Here we have the answer is no, so we're going to find out. We have the 6 here with the 10 here. Then we have the 6 here with the 10 here. Perfect. And then we have the 8 with the 12. So here's the first one, here's the second one, here's the third one. Then we simplify. Well, I get 3/5, I get 3/5, and then this is the one that doesn't match. You're going to have to simplify to know whether they're all equal to each other. Unless you have one of these scientific calculators that does it for you, you are going to have to do it. This is basic math. This is math that I expect you to know how to simplify. And we move on to our number 3. Here we have two cylinders. They want to know whether they are similar or not. The answer is there for you, but I want you to understand what we're comparing. We're comparing the height, which is the distance between the two bases, of 30 and 25. And we're also comparing, notice here, we have a diameter from side to side, which means over here we are given the radius. Well, if I know the radius is just half, so that means the whole thing has to be 20. So we're going to put 20 over 24. We do him, we do that one, we simplify. 6/5, 6/5, then it is a yes. Okay, so moving on to the next part, which is also going to be in your lesson. We're going to compare the volumes, we're going to compare the surface areas, okay? Which means we're going to have to get, like in number 3, we're going to have to get this number, this ratio. We got 6/5. Both of them are 6/5. That means that our ratio, our proportion here is 6:5. Okay? We need this. When we're going to compare volume and surface area, well, the one that we start off with is your linear. It's your scale factor. This is who we start off with. Whenever we do area, your units are squared. Whenever we do volume, your units are cubed. So, if we're going to get the surface area and we're going to use the proportion or the ratio that's given to us, well, all we're going to do is we're going to square each. If we're going to get the volume, then we're going to cube, or to the power of 3 each. So take number 4. We're going to find out the ratio. Okay. We're going to compare the height there to this height, so that's 6/3. This one is telling you that the scale factor ratios, okay, so they are already telling you that these two are similar, so you just need to grab one. I guarantee you that if you do 14/7, you're going to get 2/1. And if you do 10/5, you're going to get 2/1. So all of them give you the same ratio, the same proportion. So, given that, your initial scale factor is 2:1. What you're doing with surface area is, if you're going to go down to surface area, you have 2:1. So surface area is simply 2 squared to 1 squared, which is 4:1. And if you're going to go from your 2:1 and we're going to get the volume, then we're going to do 2⁵, 1⁵. This is 8, and this stays as 1. That's all you're doing when you're asked this question, to compare when you see these 3. If you first have to initially get this guy. Let's go to the next. Number 5, again, we are already telling you that these two are similar, so you just have to get the scale factor. So in this case, you have, they chose 4 over 6, which was easy. I mean, you can do 7, 4 over 6, or you can do 7 over 10.5. You get that? You have to simplify. If I didn't state that before, always simplify. So here is my ratio, my scale factor. So it's 2 to 3. If I'm going to get surface area, this is going to be 2 squared, 3 squared. Remember, area is power of 2. Volume is power of 3. But it's not of the one before it, it's always of the original. So, 2 squared, 4, 3 squared is 9. Volume ratio, we're going to use him, 2 to the power of 3, and 3 to the power of 3. We're using the originals. Well, 2 to the power of 3 is 8, 3 to the power of 3 is 27. Simple enough. Hopefully, if you have any questions, again, always ask me. These, the assignment I will offer, or that I'll give you on this one, I will, because it's going to be 2 lessons, I'm going to have it due probably by next Wednesday. Alright, let's go to 6 through 8. Here we go. So what's going to happen here is no longer will they give you the dimensions. Nope, they will not give you the dimensions. But what they are giving you is pieces. They're giving you surface area. Ooh, surface area, that means the ratio you're going to get goes right here in this area. So 25 over 4, can I simplify it? Of course I cannot. 25 and 4 don't share a similar factor, dividing factor. So no, that's as far as it goes. Here's my surface area. Well, this okay, we want to know what the scale factor is. So how do I go backwards? Well, I already know that this is A, this is B. Scale surface area is actually A squared, B squared, right? That goes to that one and that goes to that one. So I know that 25 equals A squared. How do I get rid of the square? Well, I square root. Bam. 5 equals A. There's my 5. Then I go 4 is equal to B squared. Well, how do I get rid of the square of the power of 2? Square root, I get 2 is equal to B. Bam. I now have my answers for the original scale factor. Doing this, the volume should be easy, because now I know the original is 5. Volume is always to the power of 3. And I know 2, and volume is to the power of 3, so if I do 5 to the third power, I'm going to get 125. If I do 2 to the third power, I'm going to get 8. Let's try number 7. Again, we're going to always focus on getting the original. We're working with volume. Here we have volume. Volume is A to the third, B to the third. So 27 is equal to A to the third power. If you have a scientific calculator, then you have access to this. If not, Google cubes or cube roots. okay, or power of 3 roots. And the internet may be able to give you a way to cube root this. But what happens here is what's called a cube root. Okay? It's no longer a square root. It's a cube root. Whatever the power is, that's the type of root you have to use. This will give you what number multiplied 3 times can give you 27? Well, that's 3. So 3 is your A. Then 64 is in your B. So cube root, you get B. What number multiplied 3 times will give you 64? Well, that would be 4 times 4 times 4. So the answer is 4. Now that you have your basic, you're able to move on to this one, because we already know that this one is A squared, B squared. So 3 squared is 9, 4 squared is 16. You have 9, 10, 11, and 12. 9, 10, 11, and 12 are similar to the problem 6, 7, and 8. The only thing is they're using their words. Okay? And they're only asking you one thing. For number 9, they're asking you to get the volume ratio. Okay? And they give you the scale factor. This is for number 9. So that one's easy. You simply do this. You find your ratio first, and then you add the power of 3 to each one. And they become 10. What 10 is happening is they give you your surface area, which means they give you A squared colon B squared. So, and they give you the ratio. They want to find out what is the actual one. So, because you're starting off with a power of 2, you have to square root. Let's go ahead and go on to the next page. This one has 4 pages worth of notes. They're meant for you just to look over. And I'm going to go over several problems just so that you kind of get what's going on. But as soon as you get it like it was in class, go on to the homework, okay? This more practice section really is just more word problems. It gives you your original scale factor setup, your surface area setup, and then your volume setup. So you keep on seeing your power of 2 and your power of 3. But here's what I want you to remember. Always reduce, always simplify your ratios, okay? If you're given either the surface or the volume ratios, you have to find your original scale factor first. Okay? That's who you need to find first. Which means you're either going to square root if they give you given area, or cube root if you're given volume. So let's take, for instance, number 1. If the cones are similar, what is the ratio of surface area of the larger to the surface area of the smaller one? Well, they're telling you they're similar. They're giving you the slant height here and this line tight here, so we have to find our ratio first. So we do 28 over 8. We simplify, or we reduce it, and we get what we need right here, 7 over 2. This is our jumping point. This is our original. Our original always starts off with A colon B. This is our original. 7, 2. A is a 7, B is a 2. If I want to get area, well, we already know area has the power of 2's. So it's A squared, B squared. So what do I do with the 7? I square it. 7 times 7 is 49. 2 times 2 is 4. This is the answer we want. Let's look at number 2. Number 2, they're wanting the volume. They give you one of the distances of that pyramid, 16.5 and 22. So they're both similar, meaning you can set them up in a ratio, 16.5 over 22, and you can reduce this, you can simplify this, and you get your simplified answer, 3/4. This is the original, A over B. It's what we were doing in the last practice, in the last notes right now. So if I want to get volume, well, I know volume is power of 3. Power of 3. So 3 to the power of 3 and 4 to the power of 3 gives you, well, 3 to the power of 3 is 27, 4 to the power of 3 is 64. Bam, you get your answer. Then we move on to examples like 3 and 4. One gives you area, one gives you volume. Always you look to get the original, which means they're giving you the area. We're going to have to square root. If they give you volume, then you're going to have to cube root. Okay, and the cube root is always looks like that. Okay, you may not be able to find it if some of your calculators don't have that access, so you look for the one that has like the little box here, or you look for the one that has the square root and has an X here. So you're able to put in that number right there. Once they give you that access, you put a 3 there. Okay. Let's see what the next page has for us. Alright, here come the harder problems. We're looking at 7 through 10. Let's look at 7. Okay. So the whole question reads, the ratio of the diameters of two cylinders is 3 to 5. Okay, so we have the basic ratio of 3 to 5. That's the original. If the surface area of the smaller cylinder is 378 square inches, find the surface area of the larger. Okay, so we're going to have to solve for x somewhere. So the original, or original, is A colon B. It is 3 colon 5. They're showing you here. And what they want to know is surface area. So that means if this is original, area is going to be A squared B squared. So I have to do that and do that. 3 squared, 9. 5 squared, 25. So now I have the area ratio. Having the area ratio, I can set it up as a fraction, right? So we have the smaller over the larger area. And if I'm solving, it says find, we're solving for the larger. Larger, since the larger is on the bottom. And we know that the smaller one has 378. This is cross multiply, then Cross multiply those two, and you get 9450. Cross multiply 9 and x, you get 9x. Then you divide, and you get your answer. Let's look at number 9. They give you volumes. They give you two corresponding distances, 20 and x. They want us to find x. But if they give me the two volumes, well, I'm going to find my original ratio from these so that I can figure out what my distance is. But first, I need to do that. 840 over 105. It simplifies to 8 over 1. We're talking about volume. This is going to be important. You pay attention to what we're talking about right now. We are starting off with volume. That means we need to start off with a to the third, b to the third. Because this is the ratio of volume, this is the ratio of volume right there, 8 to 1. So, we're going to have to cube root. So a to the third is equal to 8. That means I have to cube root each one of these. This gives me a, this gives me 2. And any root of 1 is going to be 1. So here is our original. So we set it up. 2 is the larger. That means 20 goes on top. 1 is the smaller. X goes on the bottom. Cross multiply divide. 1 times 20 is 20. 2 times x, 2x. Then you divide. Hopefully this helps. Let's look at what your homework is for this assignment. And let's see how many problems I'm going to give you off of this. So let's look at, let's go easy. I'll give you 1, 2 for sure. Let's see, there are a total of 15. Let's go with 6 problems from here. Let's go with 4. 5. 12. 14. 1, 2, 3, 4, 5, 6. That's 6 problems for your homework. 11. Take care of those. Remember these, I'm going to set, I think, due date for next Wednesday. Stay tuned for the next lesson, 11.12.